Hi and welcome to a new section in which we will further on see the features of TypeScript, and this is the third section and you're doing great. Until now we had a little practice with TypeScript and it's time to move on and learn about other great features of TypeScript. Well, what can we expect from this section? We will go through all these features that you can see on the screen. We will talk about literal types, type narrowing, optional values, a great technique called type assertion and also type intersection, and we will talk about two important TypeScript features, the enums and the enum type. This being said, let's get to work inside the next lecture. Let's now talk about two of the most popular TypeScript types and the most basic and used. We already saw this syntax. We are expressing a type, we are giving a type name, and then we can give a type value. This very basic type is called a type literal because it currently can only hold one value. And if I want, for example, to assign this type to a variable, for example, here I have a programmer type which can accept only the programmer string. Aside from giving us a very nice autocompletion right here, if I'm, for example, having a typo, then I will have a compilation error. Very basic until now. These are the literal types. Well, but these literal types are not so common because they are hard to implement and hard to maintain. Well, what's very common is a literal union type. For example, we have this type programmer and type HR. They are different positions inside our organizations. Well, we can make a type using these two other types, and I made a type right here called position type, which can either be programmer or HR. Well, this is a union of different types, and TypeScript allows union of all kinds of different types or shapes of objects. We can create union types by using this pipe symbol, and if I will now hover over this position type, you can see that it can either accept programmer or HR values. I dare to say that the most popular type of type or type alias in TypeScript is the literal union type, and this is the one right here. This is the most useful one and the one you will use most likely. Well, here we are expressing the different values or the different positions that our employees might get inside our organization. Here we can say that maybe our employees can be a programmer, an HR or an CEO. And notice this interesting syntax. Well, TypeScript allows us to have this inline, or have all the information or all the liberty of organizing things very clear. For example, this type position can be programmer, HR or CEO, but if I want to make things a little easier to read, I can format them this way, like this, and then I can call format document in VS Code, and now we have a nice indication about what positions we have in our company. These are the literal types. Well, I have created now a function which accepts a argument of type position and returns the salary based on its argument. Very basic until now. And let's look at the implementation. Here we are going through the different possibilities of position. For example, if we have a programmer, we are getting a salary. If we have an HR, we are getting a salary. And notice that we are not returning anything else for other values. Well, what will be the return type of this function? Maybe pause the video and take a few seconds to think about. We are returning 10,000 or 100,000 or 1200,000, and then we are also making a console warn in case something is not covered. Well, what is the return type? Well, we are returning two numbers or undefined, and TypeScript inferred this return type based on our implementation. Well, sometimes it is good to let TypeScript work for us and let it infer the types, but I find it a good practice to, when you are writing functions, to also write the return type at the beginning of your function. otherwise you might get into trouble. For example, here we are sure that we want to return a number, and in case that we don't have a salary for this position, we are returning undefined. But what if I'm not careful and I'm returning here a string? Well, there's no problem, I will get no compilation problem, and now the return type of this function will be a string or a number or undefined. You know, looks bad, and this is just asking for trouble. Well, I can use these union types to specify the return type of my value. Well, I want my function to return a number in case a valid position or a valid salary is found for this position, or in case of salary is not found, let's just return undefined. And now I can catch early my error right here. Well, these were basically the union and the literal types. Remember, we can combine our types all the way, and we can write simple to very complex types using these two techniques. Let's think and let's look at the value of this position. Currently, if we checked the other two values of this position, we have now, TypeScript really knows that at the end of this function implementation, this position can only have this CEO value. This is called type narrowing, and let's talk about it in the next lecture. Let's now talk about type narrowing in TypeScript, a utility that we already covered or we already used basically inside this course, but we will talk in more detail inside this lecture, and we will talk it in 4 ways. We will first see how we can narrow down literal union types, then talk about primitives, classes, and finally objects. Let's get started, and we will start with literal union types, basically the example from last lecture. You remember that we had this getSalaryForPosition function, which gets a position type argument and returns a number. Very basic. Well, if we are iterating over this programmer position right here, I will see that if I'm making this check, then TypeScript will for sure note that the value of this position, which can be either programmer HR or CEO, in this case will be programmer. So if I have here a constant best programmer, which is of type programmer, let me make this a let so I can reassign it, and inside this if clause I can say right here best programmer is our position, because at this point TypeScript is sure that the value of this position is programmer, since we already made this check outside this if clause. Well, this is basically literal type narrowing. Let's go one step further and let's talk about primitive narrowing. Again, a feature that we already basically covered inside this course. Let's say that we have a function which receives an argument of type unknown. We are receiving something from outside our system. We don't know what we get. And in this case, we are able to do type narrowing with the type of JavaScript operator. So if I use this type of argument right here, then inside this if clause, I'm sure that at this point, this argument is of type number, the same check with string. In this case, we are sure that we are narrowing down all the possible values of this argument to just string. Well, this is type narrowing. I won't get into much details about this. This is what we get. Well, let's go further on and talk about class narrowing. And here I have a more complex example. I will first explain it, and we have yet to talk about classes, but not to worry, I will try my best to explain it. If in case of primitive types we are making type narrowing with the type of operator, in case of classes or functions we can use the instance of operator. And in case you don't know what classes are, they are just a simple collection of methods and fields. I will just use the very basics inside this lecture. We will have a dedicated section to classes. But let's say, for example, that we have two classes. A class that represents the company founder, which has a method give long speech about the past. And we have a class that represents the company CEO, which has a method give long speech about how times are hard and it's hard to give salary increases and all these kinds of cliches. Well, we can make a type from these two classes, because both of them give long speeches, that we can say that we have a type long speech giver, which can be either company founder or company CEO. Both of them give long speeches, but those speeches are different. Well, how can we narrow down those speeches? We have this function give long speech, which receives a speech giver of type long speech giver. Well, and we can narrow down the values by using the instance of operator. If our speech giver is of type or is instance of company founder, then we are able to call this give long speech about company past method. Well, at this point, if I will try upstairs outside the if statement to access a function, you can see that I get no values right here, but inside the if right here I can say speech giver, and I can access this function safely. Alright, and the same with the other instance of company CEO. With this case, I'm sure that I don't have any mistakes or copy-paste mistakes or type mistakes, or I want to access a function that doesn't exist on a certain object. Well, I can do this with the instance of operator for classes. Remember, we will have a dedicated section on classes. And the last point of type narrowing which I want to talk about is object type narrowing. And for this I will use yet another example. Well, here we have a more strange type. I'll call it founder, which is a union type between two objects. Our founder, let's say that our company has two founders, a John founder and a Billy bicycle right here. And founder John likes cars, he has an Audi. Bill likes bikes and he has a bike called Wheels. Well, let's say that we are receiving a message from our founder, we want to know them better. Well, what we will receive? I have a function called meet the founder which receives a founder type argument. Well, first of all, we will see that we can meet our founder, and here we have the founder name, and you can notice right here that in case this founder, you can see that this name field is common to both options of this founder, so I can access it right here. TypeScript is smart enough to narrow down the values of this type to only this common name field of both types. Well, I can safely call this field right here because it exists on both fields. But yet again, if I'm narrowing down the objects by their name, if I say right here if founder name is John founder, then I can safely also right here access the car value, because at this point TypeScript knows that we are talking about the John founder which has a car and a car name, a value for that field. Again, I'm protected for making silly mistakes like saying that our other founder, Billy Bicycle, is driving cars. So right here, if I want to say here founder.car, I will have a compilation error and I won't make an embarrassing mistake. Well, this is the way in which we can use type narrowing. We saw how we can use it for instances that we might find ourselves into. We saw how we can do this for literal types, for primitive types, for classes, and also for objects. You can see with this type narrowing that the TypeScript compiler is getting smarter and smarter, and sometimes you will find yourself asking, well, is TypeScript really that smart? Yes, it is. Well, we saw that we can narrow down primitive values, but TypeScript also allows us to narrow down real objects with types made by us. Let's see the following example. And let's also talk about a great feature of TypeScript, which is called a type guard. And let's say that we have a type salary, which only contains an amount of type number, and we want to have a function to pay a salary, but we don't know what we will get inside that function. Well, we can use something called a type predicate or a type guard. A predicate is a function that returns a Boolean value, and in this case we are using this somewhat strange syntax if it's the first time you see it. Well, we can call this function, which is a type guard, which takes an argument, a broader argument, it can be any or it can be a union of different types, and returns back a boolean indicating that if this argument is of type what we want, then it will return true. And what is interesting about this type of functions, if here inside this space salary function we have an argument of type unknown, if we are using this type predicate right here, if is salary, and here this argument is of type unknown, inside the if check, this argument will be sure type salary. Well, and this is the way, this is a simple check for a very simple object. For more complicated objects, of course, the checks will be more complicated. But what I want to tell you is that this is a predicate. This means that this should return, or this must return, a boolean value. Well, here I can just say return true, and everything will be okay regarding the TypeScript part. We won't have any compilation errors, but of course this will be a runtime error. So we still have to be very careful when using this type guards. TypeScript just gives us a way in which we can do things in a much more easier to read way. In this lecture, we will talk about optional fields inside TypeScript. We will first learn about the optional modifier, then we will learn about optional class fields, and then we will talk about optional chaining. So three ways in which we can have optional fields inside our types. Let's start with the optional modifier. It is a very basic thing. And let's take an example. Let's say that we have a type salary, which has an amount and a currency, but maybe some salaries have a yearly bonus. Well, this yearly bonus can exist or not, is not required by anything. Well, in this case, we can make this yearly bonus field an optional field with the question mark. Simple as that. And as soon as I'm making this field optional, observe what is its type. It's not a bonus percent anymore. It is bonus percent or undefined. So this optional fields creates an intrinsic union type with the specific type and undefined. So I would simply just say, if I wouldn't want to do it like this, I would simply say right here undefined, and it will be the exact same thing, but this syntax is much more clearer. Well, let's take an example. Let's say that we have a type employee which has a name and a salary of type salary. Well, this way we can create a constant, maybe call it John's salary, and this is of type salary. It has an amount, a currency, and it has an yearly bonus. Just as well, this yearly bonus can just miss from this constant because yearly bonus it's a optional field. Well, let's go deeper into this optional point and talk about optional function parameters. Again, let's say that we have a function that pays salary, and this is a simple implementation which I just wrote right here, a lot of string interpolation. Let me explain it. So we have a function that pays a salary for an employee. Well, if the employee has a yearly bonus, we will just print out that this employee received a bonus. And again, like we saw before with conditional types, at this point, inside this if check, this yearly bonus is of type bonus percent or undefined. But we learned in the last lecture about type narrowing, so for sure inside this if clause, this yearly bonus is of type bonus percent, not bonus percent or undefined, because here we are sure that it is a defined field. Well, in JavaScript also functions can have optional parameters, and again we can make this work with the question mark inside the function signature. So if we look at this space salary, you will see that this extra work right here is optional. If I will look at its type, you will see again that this extra work is of type string or undefined, just because I made it optional. But this is a difference right here. Remember, if we talked about these types, if this early bonus is optional, an optional type, and it is of type bonus percent or undefined, if we look at the function implementation, this extra work is again of type string or undefined. But if I will not just make this extra work optional and I will make it undefined also, you'll see I will still have a compilation error, because currently the compiler doesn't like this. So in order to make this work, I will have to specifically call this function with undefined. So this is a difference between TypeScript types and JavaScript implementation. Let me reverse this. Alright, this was the optional type. A type can exist or not with the question mark. This means that it is undefined, or it can be undefined. The next thing is a much more simpler discussion. We are talking about class fields, and again, these class fields can also be optional. A little disclaimer, we will talk in detail about classes in the following sections. For the moment, let's just say that we have a class engineer which has a field tasks. Well, if I'm not initializing these tasks in any way, I will get a compiler error, and let's look at it. It says that this property task has no initializer and is not definitely assigned inside the constructor. So in order to fix this problem, I have 3 fixes. Since this is not an optional field, I can just make it right here and initialize it right here on the declaration. I could also initialize it inside the constructor body. I will write a constructor, or I can go to the compiler options right here at the strict checks, and we have here a strict property initialization. Let me make this false, and if I will make this false, then this error will go away. Well, this is a way in which we can fix this error. The best way, if we know that this field can exist or not, is to just make it optional. And again, this field will be of type string array or undefined. Let me revert this. I always want to apply the strict rules, they are very good. And the last point which we will talk about is the optional chaining right here. Again, when this feature came out to JavaScript, I was very happy, and let me explain you why. Well, we talked about optional fields in the previous minutes. Let's say that we have a type manager, and this is a brand new manager. He was just hired inside our company, so maybe he has a team, maybe he doesn't have a team assigned yet. Well, this team can also mean that can be a new team, and this team might have a Scrum Master or not. And this Scrum Master is just someone who holds Scrum meetings. So everything inside this field is optional. What would this manager do if he would want to just manage our company or his team? Well, what issue would be to just call this hold Scrum meetings field right here. But what would happen if I wouldn't specify this as optional types? And you will see that TypeScript will start to yell at us, and it will tell us that this team or this Scrum Master is possibly undefined, and this is just screaming runtime errors if I would leave things like this. One solution, it would be in the old ways, we would have to fix this like this. We will just have to fill our code base with if checks. I will just have to check if this manager team is not undefined, and then if this manager team Scrum Master is not undefined, then I can safely call this method. Well, a much more simpler way in which we can write this logic is by using the optional field right here inside our function call. And this field will mean that it will just move on only if this team is not undefined but is defined. And again, only if this Scrum Master is defined, the operation will go along. Well, in JavaScript, this question mark is called the optional operator. And there would be another way in which we can just maybe fix or force fixing the compilation error regarding this option regarding this problem I just showed you. Let's just say right here, there's another way in which I can tell the compiler, hey, leave my code alone, I don't want you to mess up with it, I know better. And that is by using the non-null assertion operator. And this is the question mark right here. At this point, I'm telling the TypeScript compiler, hey, I know better, I'm sure that this particular manager right here surely has a team, and surely that team has a Scrum Master. Of course, I see this as a little bad practice, you can never be sure, and I guess the other way around would be just better. Or again, if you're not sure, write more meaningful types. And the conclusion regarding our lecture would be that if you are new to JavaScript and also to TypeScript, and you are learning TypeScript, you never know what is a JavaScript feature and what is a TypeScript feature. And as I said before, the easiest way to find out is to just compile your code. Let's compile our code. So TSC, and let's look at the generated code right here. And if we look at our generated code, you'll see that this is using the optional operator. So we understand that this optional operator is a JavaScript feature, but the non-null assertion operator is a TypeScript feature. Let's move on to the next lecture and talk about type assertion. In this lecture, we will talk about type assertion. And what is type assertion? Basically is forcing a certain type to a variable. And what I mean by that? Let's look at the following types, which I have already wrote. Let's say that we have 3 types describing certain jobs. We have a type that describes a simple job, which only has a coding language and a source control. We have a type that is describing a more complicated job, which has a coding language, source control, the same as the simple job, but also has 2 new entries that has many meetings, which is always true, and an array of reports to be completed. And yet again, we have one more type of job, a quality job, QA job, which just has 2 entries, a scripting language, and has automated tests entry. Just simple ways in which we can describe certain technical jobs. Let's also write some variables with these types. Well, I have wrote some variables right here. We have a simple job, which has a coding language, TypeScript, and the source control Git. A complicated job which also has some reports to be completed, and a QA job. You know, just some very basic types. Now, what we can do with them, and let's imagine ourselves that we are in a position to have a simple job. Well, I can write right here that my simple job, let's say that I have a simple job, but I want to take the extra mile and do a complicated job. I have a great day and I want to say, hey, I want to do a complicated job. Well, I can assign this complicated job to the simple job. Why is that? Because the complicated job has the same fields as the simple job. It has the coding language and the source control with the same types as string. That's why I'm able to do this. Even if the simple job is of type simple job and the complicated job is of type complicated job, I can assign this complicated job to the simple job. Well, let's take the other way around, and let's say that I have a complicated job, but I have a bad day, so I don't want to attend any meetings and I don't want to complete any reports. So I can say complicated job is simple job. Well, and at this point, TypeScript doesn't let us do this, because yeah, we can't just downgrade things like that. It's not for us to just say I don't want any meetings. You have a complicated job, you must take it. Well, this is what TypeScript says, and it will complain. This is a compiling error. It will complain that hey, your complicated job is a complicated job, but it doesn't have these fields, has many meetings and reports to be completed. TypeScript says that you can't get away with this. But yes, we are smarter than the TypeScript compiler, and in this case we can force the type to this complicated job. So here I can simply fool the TypeScript compiler, or better fool, I can say, hey, I know better, and I can say right here that my simple job, I can take it as a complicated job, and then the TypeScript compiler will be happy. And this is basically type assertion, you know, getting rid of these TypeScript warnings or errors and trying to say, hey, I as a developer, I know better. We already know that until in this course, when we are trying to be smarter than the TypeScript compiler, it's not always a good practice. Well, let's move on things with the next step. Again, let's say that I have a complicated job, but I have a day in which I don't want to do anything inside my job. I want to take the job of a QA engineer just to see how it is. Well, I can say right here, complicated job is the QA job. Again, of course, TypeScript will complain. like we did before, and the same, again it will tell us that is missing the following properties, so on. No problem, I can call just as I did before, complicated job. But TypeScript again is not full, and it will tell us, hey, you are making a mistake, you know, because this is probably a mistake. And why is that? Because why TypeScript let us one step ahead, that we can change the type of this simple job as complicated job, but it won't let us change the type of this QA job as complicated job. The reason TypeScript let us right here is that this simple job and complicated job have fields in common, while this QA job type and complicated job types don't have any fields in common. This way we need to perform something called a double assertion. So if we really want to do this, we first need to cast as any or as unknown. So I can say right here as unknown, and then as complicated job, and this is called something like a double assertion. This is a simple assertion and this is a double assertion, basically forcing the types to these variables. Well, I want to show you next a different syntax. This is a different syntax, but this has the exact same meaning. I can make the type assertion with this syntax, these brackets right here, and this is exactly the same thing. I'm taking this simple job and I'm changing its type to a complicated job, so I can assign it to a complicated job variable, and the same with this QA job. Well, the next very important question, maybe the most important question, is when can I use this type assertion? Well, and one way in which we can use this type assertion is by building objects in steps. And the advantage of doing this is that we have autocomplete assistance from VS Code. For example, here I have initialized this complicated job made in steps, which is in the beginning a simple object, a empty object, and I typed it as complicated job. Well, here I can say complicated job made in steps, and I can assign everything right here, and I can be sure that I don't have any typos. You know, if I have a typo right here, TypeScript will complain. Well, this is the advantage. The disadvantage is that I won't have any compiler error if I will make an incomplete object. You know, this is the disadvantage. And you may also, a last note, you may know this syntax from other languages like Java or C#, where we call this technique typecasting. Well, this is in the case of TypeScript, this is not typecasting. We would make a mistake if we would call it like this, because typecasting happens at runtime. You know, what we are writing here happens at compile time, so it's wrong to call this typecasting. The proper way to call it is type assertion. In this lecture we will learn about TypeScript interfaces, but in order to do this we will break this lecture into smaller topics. First of all, we will learn about type extension or intersection. Then we will learn about TypeScript interfaces, which are fairly similar to types, but there are a few key differences. And then we will see when to use types and when to use interfaces. Let's get to work, and first of all, let's talk about type extension or intersection. And let's look at the example from the previous lecture when we had two types, a simple job type and a complicated job type. And as you can see, for the complicated job we have a fair share of duplicate code. Is there a way in which we can make rid or get rid of this code duplication? Of course there is, and that is type intersection. And let's look at another example, another piece of code I've prepared for this lecture. In this file we have again a type of simple job and a type of complicated job. But this complicated job, what it does, it takes the simple job type and it adds some new things to it. For example, this complicated job at this point still has a coding language as string and the source control as string, but it also has some additional fields, like has many meetings and reports to be completed. The documentation says that this technique right here is called type intersection, but the mental model would be more, or would look more like a type extension. And I guess the reason this is called type intersection inside the documentation is that if we would have the same key right here inside also this new type, then we would have any problem and it would just intersect the two. And if we have the same field right here and also the same field right here, of course the new type won't have two fields with the same name. That's not possible. I guess that's the reason this is called a type intersection. And as you can see, by combining or by extending this simple job type, we can have a get rid of code duplication and achieve the same functionality. Well, let's also talk about how these types and what their relationship is with TypeScript classes. Well, also in this file I've created a new type called meeting holder, which has two fields. First of all, a field with maximum length and a function which holds meetings. If you've worked with classes, maybe in JavaScript or in other programming languages like Java or C#, you know that classes can be programmed to interfaces of, or if types give the shape of an object, maybe the interface gives the shape to a class. We can take this mental model. And I've created this example to look side by side at types and interfaces in TypeScript. Well, classes in TypeScript can also implement types. You know, and if this class project manager implements this meeting holder, this means that for sure this class needs to have a field of maximum max length of type number, and of course he needs a method hold meetings. You know, this meeting holder shapes the, or gives the shape to this project manager class. Let's now talk about interfaces, and let's talk about interfaces in comparison with types, because in TypeScript interfaces are fairly similar to types, but there are a few key differences. Well, I have created a new file which holds some interfaces, and as you can see they are fairly similar in the way that we can use interfaces just like we used types to give the shape or to match the shape of objects, you know, to describe the shape of objects. Just like we said on the left that we have a type simple job, we can do it on the right, we can have an interface to a job. The difference at the first glance is a syntactical one. Types are made just like we are declaring objects, you know, we are assigning objects. Interfaces are like we are declaring functions like this. You know, we don't have an equal sign right here. This is a difference, but this is just a syntactical difference. The functionality is exactly the same. Also, just as we did before, we can extend types. We can also extend interfaces, and also interfaces can extend types, but I don't want to get into that. So just as before, interfaces can extend other interfaces, take their functionality and also add something new to them. Again, we can use interfaces to give shapes to objects. You know, if we have typos or something like that, we should have compilation errors just like we did with types. Well, as you can see, they are fairly similar. And even interfaces can give or can give the shape to classes. Well, we talked about the similarities between types and interfaces. Let's also talk about the differences between types and interfaces. And let's talk about a feature that interfaces have and types don't. For example, we have this meeting holder interface, which of course has this function holds meetings. Well, let's say that in our organization we have project managers which implement this meeting holder and they hold meetings. But let's say that inside our organization we have a problem. Project managers, some of them never end their meetings. So we have a small problem to this. Well, we can fix this problem and fix all the implementations of this meeting holder declaration by having a separate meeting holder interface. And instead of this holding meetings, let's just make this to just end meeting. You know, and as you can see, this is not a compilation error. TypeScript allows us to have multiple interfaces with the exact same name. And as you can see at this point, our project manager class that implements our meeting holder has a compilation error because he also needs an end meeting declaration. So let me write this down right here. Alright, this technique is called interface declaration merging, and to be honest, in my opinion, is a little misleading feature of TypeScript interface and maybe sometimes hard to read. This is just my personal opinion. Maybe you will have a great time using this TypeScript feature. You know, maybe if you are using an external library which has a declaration type and you want to also add something to that library, maybe like a REST client response, which you want to be unique across your workspace, then this declaration merging would be a great solution for you. Well, let's talk about other differences between types and interfaces. Well, we saw that interfaces also had this new feature, this declaration merging, and also maybe they have the advantage of having a more familiar syntax for developers that come from other languages like C# or Java, where we have interfaces. Also, something that types have and interfaces don't have is literal types. We saw previous inside this course that we can use literal types, maybe the most usual way in which we will use types. This is not possible with interfaces. And also another important feature that we will talk in the future lectures of this course is complex types. It's harder for us to have complex shapes for interfaces, but we can make very complex types in TypeScript. Well, we saw in this lecture what interfaces are and how they are compared to regular TypeScript types. In this lecture, we will learn about TypeScript enums, and they are a special kind of TypeScript feature, a feature that many don't like or even hate if you will search on the internet. Well, I want to say that TypeScript enums are a language feature and we can use them just fine if we use them the proper way. And in this lecture, we will see what they are and how we can use them the proper way. Well, simply put, not just in TypeScript, but in many programming languages, enums are simply a group of final constants that can have a value and they are tied together by a specific mean. Well, this is how enums look inside TypeScript, and they use the enum keyword and then the name of the enum and then with its possible values. Simple as that until now. We can use these enums inside our types. For example, we have our type employee, which has a position of type enum. The special thing about these enums is that they exist after our code is compiled. If our types don't exist after our code is compiled, well, our enums will exist at runtime. And the other important thing about them, a difference to other TypeScript features, is that the compiler will directly assign them values, integer values, if we don't specify otherwise. For example, you can see that because this programmer is the first entry in this enum right here, it has the value 0, the HR has the value 1, and the CEO has the value 2. Well, let's see how this code looks after we compile it. Well, I have compiled it and let's look at the compiled code. As you can see, it is a little strange, and I guess this is the reason that enums get so much hate. Well, it's simply a function for this position, and yeah, it's a function with a function. Well, it's a strange code that is generated, but if we use enums the way they are supposed to be used, we shouldn't have any problems. And speaking about problems, let's see one big problem that we might encounter while using enums. Well, let's say that we have a function that pays the bonus for our employees. This function takes an argument of employee, of type employee, and based on his position, the function will pay a bonus to our employee. Well, this is a very bad way in which we can use enums. Why is that? Well, let's say that we want in our function to pay the bonus at some point for our CEO, and we know that from this position entry right here that the CEO has value 2. Well, what will happen if sometimes in the future these positions will be extended and maybe we will have a manager entry right here? Then in this point this manager will have position value 2 and the CEO will have value 3. But here we wanted to pay the bonus for the CEO bonus. Well, in this case the manager will get the CEO bonus and this will be just embarrassing. Well, this is a bad way in which we can use enums. The proper way in which we can use enums is by comparing them directly to the enum values, and this way our function is safe even if we extend the values right here. Also, I saw that many libraries use enums inside their SDK. For example, the AWS SDK, which I'm more familiar with, uses these enums and it assigns string values to them like this. Well, this kind of enums where we are assigning the values ourselves are more safer, we can say, and maybe more easier to read. And again, the problem with this implementation is that we have a little code duplication, but I guess that's not such a big problem. Well, but what alternatives we have to enums if simply we don't want to use them inside our code base, or we don't like them like it's the popular belief? Well, since we are using TypeScript, a great alternative to enums are simply our literal types. For example, we have a type of position types just like we saw before inside our course, and they work just fine. This is great and we can also use them. One important feature of enums which is not found inside the position inside the types is that we can add documentation to our enum values. For example, inside our enum declarations we can add a documentation on the fly for different entries inside our enum. For example, the kind of information that we can't find no matter how clear we write our code. Some information that only us developers have at the time we are writing our code, or maybe if we are writing a library, make our code easier to read. You know, for example, in our case, our CEO must receive a very big bonus, and this is just an information we have when we are writing our code. Later on, when we will use this code right here, I will implement this pay bonus function, and I can read right here that, hey, the CEO must receive a very big bonus. This is just the information, I can get it right here, so I don't make any embarrassing mistakes to my CEO. This is just an important point I like about enums. Of course, we can add overall comments also to our types, just like this, but yes, this documentation we will only see it for the whole type, not for individual entries inside our types. Well, let's proceed with one final entry inside our enums lecture. Well, let's say that we have a function that pays the annual bonus for our employees based as a percent based on their position. For example, our programmers have a percent of 0.2, our HR have a 0.8, but our CEO has a much bigger bonus because yes, he's the CEO and he can do that. Well, do you notice something wrong with this function? And I will tell you, yes, there is. The problem with this implementation is that if we are switching over the position of our employees, maybe in the future this employee extension, or no, this position type will have or will receive multiple new entries. We will get new positions inside our company. If we look at our position right here, earlier in our lecture we added a new position called manager. Well, the problem with this implementation is that we forgot to pay our managers a bonus, and they will get very mad if this happens. Well, how we can enforce that we are iterating through all the entries inside our enums or inside our types while writing a function for them? We will see this in the next lecture by using a very special type from TypeScript, the never type. In this lecture we will talk about an interesting TypeScript type, and that is the never type. And yeah, the big question is when we would use this never type. Let's say that we have a type CEO and a type founder, a literal type. Well, what happens if we try to intersect these two types? Well, I have here a type CEO and founder. If I will hover over it, you will see that this is of type never, because yeah, two string literal types intersected, they will never happen, or nothing will happen inside the intersection of these two types. Other type that will never happen is maybe us for trying to intersect a string and a number type. Again, the type of this will never happen is never. Well, these are just edge cases, and you will maybe never use this. But when we can actually use this type never? If, for example, you will have a function that will never return, maybe a game loop or something at the very beginning of your system. Usually you don't do this in JavaScript, but maybe you will do. For example, this function will never return because this is an endless loop. A while true is an endless loop. Well, we can safely say that this function returns never, because it will never return. Well, and this is not a compilation error. A more common way in which we can see the never type is when we do type narrowing. For example, let's say that we have a function, I called it do stuff, I lack inspiration, and this function requires an argument which can be of type string or number. Well, inside the body of the function, we can narrow down the values for these types. For example, if we are making a check that this type is of type string, well, inside this if check, for sure this argument will be of type string. Then we are returning. The same with number. In case this argument is of type number, well, inside this if check, the argument is of type number. Well, what type will be our argument after these two checks? Our argument will be of type never, because anyway we will never reach this line inside this implementation. Well, we can take this kind of type narrowing to build exhaustive enums, and let's remember the example from the previous lecture. I will paste here the code. You remember in the last lecture we had an enum of positions, and then we had an employee, and we had a function that pays the annual bonus for different employees. Well, we want to make sure that for all our positions we will give them a bonus. This is the nice thing to do. Well, and in our case we are covering all the three positions, because currently our position is of type programmer, HR or CEO. And as you can see, in what way did we achieve this exhaustive enum? I will say here that I will save these remaining values of our position, and I have type annotated as never. And as you can see, after we went through all the positions or all the possible positions inside our enum, the type of the position will be never. And in case these positions will be extended in the future, maybe I will add here a manager entry, then this position will be just fine. But if we look downstairs at our function implementation, we will get a compilation error, and TypeScript will warn us, hey, you wanted to make an exhaustive check, but you have one value remaining. You know, for example, and this way, if I hover over this, you can see that at this point my position is not never, but is of type, or its value is position manager. And this way I can make sure that I leave no one behind inside my switch cases.